Adding a data source, when we find ourselves in situations with a lot of uncertainty, like COVID times, sometimes what we want to do is add a data source relatively quickly. And we want to be able to do that without having to change the software. So to enable shorter time to value in adding such a new data source, AutoML in itself is not enough. So we've complemented it with a couple of key techniques. The first one is that data is ingested into the system using a self-described schema that is combined with metadata, which informs the feature engineering. And the intelligent data fusion, which we're going to see on the next slide. This can be combined with discovery tools that allow the system to be used to iterate through a number of possibilities and find out things like at what aggregation level a particular data signal should be used. In particular, if this particular signal happens to be quite sparse in terms of the number of data points in it. Sometimes it's best to aggregate it a certain way before ingesting it into the system. So what do we mean by data fusion? If you have some of your data at the product level, for example, with some location and at a monthly frequency, this could be sales data, for example, and you want to mix that with a financial index that is relevant to a particular sector of the industry that is published on a daily basis, together with sentiment data that potentially at the brand level that you might be acquiring on a weekly basis, and then weather data that is available on a daily basis. When you want to mix all of that together, what the system does is what we call data fusion. And it will create a unified feature representation that it will then pass to the rest of the feature engineering steps in the AutoML framework. So when adding a new signal, it will simply add one more here and create a new unified feature representation and pass that on the next time we want to forecast. This is what an example of explainability looks like in the product. So in the context of a demand planning screen, there are specific forecasts on certain dates, and by clicking on them, it opens up a diagram that shows some of the feature contributions that push the forecast upwards, as well as some of the feature contributions that push the forecast downwards. And one thing to keep in mind, though, is that this should be really used as correlation and not causation. But still, it really informs the user as to what it opens a window as to what the model actually picked up as important features for this particular forecast. And should anything look a little out of place out of these explanations, it allows the data scientist and the specialist with the domain knowledge to circle back to the way that the data is configured for the system to generate results.